So, sticking with using mental math or trying to see patterns with these products of binomials, today we're going to deal with the squares of binomials, or what we'll also call as binomial squares. So a binomial square is something like this. So this is a binomial. It has two terms, and it's being squared. So the number one mistake most students do is they think the solution to this is a squared plus 49. They think that you distribute that square into the a to get a squared and the square to the 7 to get 49. That is incorrect. I can tell you 80 million times there still are going to be students who will try to shortcut this and do it in this manner. Unfortunately, that will be a bad mistake for you. So number one is you gotta remember not to make that mistake. What we have to think about is what's the base of this exponent? Well, it's the quantity of a plus 7. So we should know that we have a plus 7 times a plus 7. And now we can use FOIL. First, outer, inner, last. First gives us a times a, which is a squared. Outers gives us 7a. Inside gives us 7a. And the lasts gives me 49. We notice that we still have like terms as our outside and inside. So my solution is going to be a squared plus 14a plus 49. That's what a binomial square will produce. Okay, very important to do it. We could have understood that, you can also do the FOIL technique on the shortcut, that it's this plus this, and then this times this. So 7 plus 7 is 14. 7 times 7 is 49. We can also use that shortcut. And remember, that only works when your firsts are a variable with no coefficient. So keep that in mind. So important for you to know is that we can always use traditional FOIL. We don't have to use any shortcuts. We can use first, outer, inner, last. We can use it when we have a binomial that looks like this. We can use it when you have a binomial that looks like this, where they're conjugates. We can use FOIL, and we can also use it when it's a binomial square. So we can still use FOIL. We would just rewrite it and then use FOIL. So don't ever fall away from the traditional multiplying of binomials, FOIL, or double distribution, double D. So you can always utilize double distribution when you are multiplying two binomials. The shortcuts are just to save time and be efficient on assessments and just to notice patterns. So on Friday or Thursday, we learned about binomials with opposite signs, which we called conjugates. And we knew that conjugates, when we did it, our outside and our inside ended up being opposites. So they cancel each other, and you're just left with the first squared minus the last squared. So you just end up with the firsts times the firsts and the last times the last. So that's your shortcut. Remember, you don't need to FOIL in these cases. You only need the first squared minus the last squared. The O and the I cancel each other out. All right, today we're going to do binomial squares. So we have each of these is a binomial and each one is being squared. So we can write it out as a product of two binomials, and this is what you're going to get. So what I want you to do is let's look at all these solutions And what patterns do we see? What do we notice that is consistent in all of these answers? So the first thing that is most obvious, I think, is that your second sign is always positive. So every single time you multiply a binomial square, it will always produce a positive. It doesn't matter if your sign in your binomial is positive or negative. We have both situations. That second sign, we call it a second sign. We call this the first sign and the second sign. I know technically it's a third. I know, didn't mean to do that. I know that this technically is the first, but for this case and purposes, we'll call this the first sign and that the second sign. We notice that our second sign is always going to be positive. And think about it, because the reasoning behind that is we have a positive times a positive, which produces a positive. We have a negative times a negative, which produces. Remember that this third term is always a product of these two positions. So since we are squaring, we know that the signs are going to be the same. So every time that the signs are the same, our third term is always going to be positive. So that's number one. That's the first pattern we should notice. The next pattern that you should notice, at this point you should start becoming very observant to these special numbers. And everybody should notice that they are perfect squares because you're multiplying the same number. Positive 1 times positive 1 gives us positive 1. Negative 1 times negative 1 gives us positive 1. Positive 2 times positive 2 gives me positive 4. Negative 2 times negative 2 gives me positive 4. 3 gives me 9. 4 gives me 16. So all of these third terms are always going to be perfect squares. And hopefully you noticed, hey, so are my firsts. So very similar to difference of squares, because we have almost identical, well, we have identical in this case, but almost identical in difference of squares. So something to be cognizant of. Let's erase this a little bit just to give it a little space. Okay, so that's two things we should notice. So let's do this. Let's write, I knew that was going to happen. I put down the pen. I think you heard me put down the pen. So let's do this. Let's list what are the characteristics. Well, the first thing we should notice is that each one has 3 terms. The next thing you should notice is second sign is positive. The next thing you should notice is that the first and third terms are perfect squares. Now here's the tricky part. That fourth thing that you need to notice is your middle term. How did you produce this middle term? This number. This number is produced. And let's go back here. Notice what it produced, how it's produced. So I did it again. Notice my outside and inside here. Notice that my outside and my inside were identical. Why is that the case? Well, because we're multiplying the same two numbers. So notice that my middle is doubled. It's 7a times 2. If we look at another example, that's difference of squares. That's difference of squares. Well, let's do another one. So if I do, let's do the quantity of x plus 10. Yes, quantity squared. So it's x squared plus 10x plus 10x plus 100. Because remember, this is, so first, my inside and outside are going to be the same. 10x and 10x. So my answer is going to be x squared plus 20x plus 100. So this was 2 times 10x. How did I get that 10x? Well, notice that my first times my last will give me my 10x. So if I multiply the first times last and double it, that ends up being my middle value. My middle is 2FL. So let's go back to here. So my middle term is always going to equal 2FL. 2 times the first times the last. So A times 1 times 2 gives me 2A. Let's go down here. A times negative 4 is negative 4A times 2 gives me negative 8A. Let's look at this. Let's do another one. So if I have B minus 6, quantity squared. So what's my first term going to be? Right? First thing, it's going to be B squared. What's my last going to be? Positive 36. It's going to be positive because negative 6 times negative 6 is 36. And how do I get my middle? I multiply my first times the last. So negative 6 times b equals negative 6b, and then I want to multiply it by 2, which gives me negative 12b. So the quantity of b minus 6 squared gives me b squared minus 12b plus 36. Let's try a couple. So let's try these two. So pause it, multiply it, see what you end up with. All right, so we're going to get a squared plus 12a plus 36. And we get the 12a because you have 6a plus 6a. What's my next one? A squared minus 14a plus 49. Always going to be plus because you have a negative times a negative is positive. So we can look at it. The shortcut is always going to be my first squared plus 2FL plus L squared. So this is my first, a squared. My middle is going to be 2FL. 2 times F times L, 2 times A times 2 gives me 4A. And then my last squared. So 2 times 2, 2 squared is 4. So that would be my answer. All right, let's try these. These are a little bit more complex, especially number 3 and 4. So pause the video, take a gander on this, and when you're ready, unpause it. So my answer here is going to be f squared, my first squared, plus 2FL, x times 9 is 9x, double that is 18x, and then my last squared, 9 squared is 81. My first squared, a squared is a squared, and 2FL, a times negative 12 is negative 12a. Let's double it, and then square my last. Negative 12 squared is positive 144. Just because it's more complicated, oh, I didn't see that boy in there, was hiding in the bottom. Just because it's a little bit more complex doesn't make it any harder. Let's square the first. 2x squared is 4x squared. My middle is going to be 2FL. My f, 2x times 3 gives me 6x times 2 is 12x plus 9. Let's square my first, x squared. Let's multiply my first and last, x times negative 4y. X times negative 4y would give me negative 4xy, and now let's double it. Times 2 would give me negative 8xy. And now let's square the last. Negative 4y squared gives me positive 16y squared. Oops, that didn't work. And this one, ooh, baby. Let's look at this. Let's square my first. That would be u to the fourth, excuse me. Let's multiply my first times last and then double it. So u squared times negative 10 is negative 10u squared. Double it is negative 20u squared. And negative 10 squared gives me positive 100. Oh, that's a good one. All right, we remember that. So we're asking the factor, what are the signs? So, oh, yeah, sorry. Now, so now let's reverse the process. What if I give you the expression? So what if I give you x squared minus 6x plus 9? Can I factor this into a binomial? Is this a binomial square? So does it hold those 4 characteristics? Remember, the first characteristic, does it have 3 terms? Does it have 3 terms? So are there 3 terms here? 1, 2, 3. Yes, it has 3 terms. Next thing, is the second sign positive? Is the second sign positive? Yes, it is. The next criteria, are the first and the third perfect squares? So, is my first and third, are my first and third, is this a perfect square? Yes. Is this a perfect square? Yes. We're good here. And then my fourth one, this is where it gets challenging. Does my middle equal 2 times the square root of f times the square root of my last? So does my middle, 6x, does that equal 2 times the square root of x squared times the square root of 9? Well, the square root of x squared is x, the square root of 9 is 3. 2 times x times 3 equals 6x. Yes, it does. So we get green on all those. So I know that this is going to be factored into a binomial square. So what's my first? My first is always going to be the square root of my first. So the square root of x squared is x. My last is always going to be the square root of my last. Square root of 9 is 3. And here's the cool, nice, easy thing, is that sign will always go there. That will always be the sign of your binomial square. All right, not easy, but I think you can handle it. Let's try this. And it has to hold those 4 criteria. So a squared plus 22a plus 121. 3 terms, yes. Second sign positive, yes. First and third, perfect squares. Yep, 121 is a perfect square. Does my middle equal 2 times the square root of f times the square root of L? F stands for first, L stands for last. So 2 times the square root of a squared times the square root of 121. Square root of a squared is a, square root of 121 is 11. That gives me 22a. Does my middle equal 22a? Yes. So I'm going to create a binomial square. Square root of the first is a, square root of the last is 11, and I take the sign, the first sign, which is positive. Nice. Last one, let's look at this. What if I have m squared minus 5m minus 25? Does this produce a binomial square? look at that and think about it for a second. Is that a binomial square? Does it have 3 terms? Yup. Is the second sign positive? No. Since this is not positive, we know that this cannot be factored, is not a binomial square. So I cannot factor it to a binomial square. I might be able to factor it to something else, but I definitely know it is not a binomial square. So good luck. Probably one of the more challenging sections that you've been introduced to at this point, but I'm certain you can get it. Come and see me if you have questions.